Hello everyone, my name is Domagoj Korman and I am an Android engineer here at Infinum. And today I'm going to tell you how to stop wasting time fixing bugs with test-driven development. Basically, we Android developers have common problems that we meet every day, and the most common problem is Gradle build running. Basically, you get this every day and you start your application. The Gradle build is running, you wait, and then you get a message installing APK. And then, after some time, your application successfully installs. But actually, you get an exception, and you need to rerun the application. That wastes a lot of time, and you don't want to waste time waiting for your application to run. So the other problem is implementing flows. Basically, if you have an error on forward screen, you start the application, you manually navigate to the forward screen, and what happens then, your application crashes. So to debug it, you have to rerun the application, come back to the forward screen, debug it, and fix the problem. That takes a lot of time, and you actually don't want to do that. So I have a solution. Basically, the solution to this problem is test-driven development. Now, test-driven development is a process where basically you first implement your tests, and after you implement your tests, you want to implement your application logic so that your tests stop failing. And as long as your tests are failing, you continue to implement your application logic until you fix all the problems. Why is that good? Because tests are debuggable. Basically, everything you do when you run your application in a debug mode, you can do if you run the test in a debug mode. So you can set a breakpoint somewhere where it failed, and you can debug there with you will see values and everything that caused the problem. And the main thing when you run your application, it actually takes around 2 minutes to run, but when you run your test takes around 10 to 15 seconds to run, so you don't have to waste your time while waiting for the application to run. The second thing is you can mock responses, and you can mock yourself anything you want. So, for example, if you don't have an API that is still ready for the production, and you know what kind of responses you will get once the API is ready, you can write the response in a JSON file, mock it in your test, you write the test like you're really getting that response, and if your test confirms that your application is handling that response, then you will know for sure that once you run the application with a production API, your application will for sure work. And the best thing about this, you can easily handle multiple user types. Often applications have multiple user types that you need to handle. For example, a normal user and a business user. And to test that, you actually need to have 2 different test accounts. And to test that, you need to log in with one test account. You manually test everything, then you have to log out, then you log in with the other account, test everything, and that is really boring and takes a lot of time when you can do the same thing with tests, but it will take around 30 seconds to run and you will know whether you handle it correctly or not. So what we use to implement tests, basically we use Robolectric. Robolectric is unit test framework. It mocks Android, and basically it runs your application it runs tests on JVM, so you don't need an actual device. The second thing we use is mock web server. Basically, it's a web server for testing, and it enables you to mock anything you want. So you write mock responses, mock them into your tests, and test the application with those responses. We also use Dagger. Dagger is not exactly used for testing, but we use it for dependency injection. Basically, we need a way to inject a mock web server into our tests. So we use Dagger to inject mock web server into our tests and still use a real web server in our application. So now I'm going to tell you a story how test-driven development helped me and how I actually became a better developer by doing test-driven development. But at the first, I was a noob, and I basically didn't even know what tests were. I was here at Infinum several months, and I didn't have a lot of experience, and I never wrote a single RoboElectric test. And to be honest, I found that RoboElectric was black magic to me back then, because I had no idea how it works. But then Dino came to me, and he told me, hey Domagoj, you're starting on a new project, and do you want to learn how to write tests? The problem here was that I just started working at Infinum, and we all know that this actually was not a question, but he actually said this, and I kind of knew that I'm screwed, and I have to do it. So, a few project specifics about the project that I was working on. It had dynamic layout based on the API responses. Basically, in an API response, I would get a Boolean, which would tell me should I enable or disable some button, and I would have to generate a layout by the response. Then the project also had multiple user types. Basically, I had to handle, I think there were 3 user types, and the main problem was that API was still not ready. And the frustration begins. Basically, I had all these problems. I didn't know how to set up Dagger for tests. I didn't even know how to set up RoboElectric, and I didn't even know how to write tests. So I basically spent over a week looking at other projects, and I just tried to apply the same approach that they applied there. It worked, but not completely. My tests still failed, and to be honest, I wasn't sure if it's test's fault or I failed somewhere in the implementation. So after lots of trial and error, I kind of understood how RoboElectric works, and I successfully implemented that feature, and then came the next feature, and also came the enlightenment. I got the new feature that I had to implement. It had a flow of 5 screens or so, and I had to implement it for different user types, which I really didn't want to test manually. It would take me a lot, it would basically waste a lot of my time just trying to navigate through those screens. And as I said, the API still wasn't ready, so I simply couldn't start without mocking. So I did it with test-driven development. How I did it, basically, I first created a layout for one screen. After that, I wrote tests for that screen. After I had implemented tests, I wrote the application logic for those tests. And in the end, when everything is working, you simply have to fix the layout. So the first thing that you do is you implement a layout, like this example. And you have to do it because when you write your tests to test button clicks or something, you need to have an ID of view that you're testing. So you can't start writing tests if you don't have IDs. So you must write a layout first, create the layout first. Basically, it's awesome because when you look at the screen, you can see what the user can interact with and what you need to implement the test for. For example, we have a button, and then I know that I have to implement a test that will handle the button click. And so on, you basically get the general idea of what you need to test. The second step is create the test class. And after creating a test class, the thing that I like to do is declare all the test cases that can happen in that test class. Basically, this serves as a great documentation because you just have to enter your test class and see what you need to implement later in your application. And also, if you do this at the start, you won't have to worry later if you forgot something. After writing declarations, you implement your tests. This is a simple test. Basically, as I said, the project had dynamic layout based on the response. So this response was almost empty, so I simply checked with test if all the views are hidden except some typo and stuff. After you write all your tests, you basically become the code monkey, because now you don't have to worry about application logic. If you screw something up while implementing your application logic, your test will fail, and you will know that you failed, and you will simply debug it, fix it, and it will work. So this is awesome because you really don't have to think about the application logic while implementing it. Also, after you finish implementing your application logic, you have to fix your layouts, as you can't really test how the layout looks with unit testing. So now you start the application and set margin or padding or whatever in your layout, but you for sure know that your application won't crash because you just covered it with tests. There are some requirements to do test-driven development. The main thing is experience. You really can't start writing test-driven development if you don't have any experience, because you need to be able to write testable code. To write testable code, you need to have experience, because if you write spaghetti code, you won't be able to test it. And if you actually write tests for spaghetti code, your multiple tests will fail, and you want to know what really caused those tests to fail. The second thing that you need is API specification. Basically, you need to mock yourself responses. And if you don't know what kind of response you'll get, you can't write a test for that. So if you write tests with some false responses, later you will have to re-implement everything, and that doesn't make any sense. And the last thing to do, you need the will to learn Roboelectric, because Roboelectric is kind of weird. It runs everything synchronously, and everything that is async, you need to implement it synchronously. So some things like animation or navigation are handled differently in Roboelectric. So you need to really have a will to learn it and get used to it, but once you do, it gets much easier. So test-driven development is awesome because you can actually debug tests. You don't have to debug the application on your mobile phone, and you can mock yourself all possible responses. You don't need a working API, because you basically mock yourself everything, and you later just include the API in the production. Also, the awesome thing is you can test any screen in a matter of seconds. So that means that flows are really not a problem, because you test a single screen in a flow and you don't have to navigate through all the screens. And you can easily test it for multiple users, because you simply want yourself a different response. The awesome thing is you can easily do some request change later on, because you get a request change and change something in a code, and let's say you screw something else, the test will tell you that it's not working anymore and you have to fix something else. So I really encourage you to try test-driven development, and that would be it for me. Thank you for listening, and do you have any questions?
While you were developing the app from scratch using TDD, it happened that tests influenced your architecture. Or to rephrase that, did it happen that you discovered, using tests, the flaws in your architecture? Like, for example, using unnecessary global state, any global state, or screwing up dependencies, or not being able to mock actually the object at all, something like that.
Well, to be honest, I never started from scratch, but I started a feature from scratch, and we always use the same architecture. So I always write my tests so I can test the architecture that I know that I will implement later on. I mean, I didn't have a problem that my tests throw me to some wrong way, if you mean that. That's it. Any more questions?